Hello everyone, my name is Pablo Montes and I'm part of Telefonica NFV Reference Lab team. I have decided I'd like to make my own personal contribution to this open source project we have started, this is OpenMANO, by recording in my free time a set of video tutorials about it. In the GitHub site you have all the OpenMANO description and the source code, but anyway in these videos the idea is that I ease the learning about the usage of OpenMANO. Since last week, as part of the Movilforum program, we did a workshop with Intel. The idea of this first video is to show you what we did, and in that way you will learn little bit about OpenMANO. You have all the slides available in the Movilforum website. So here you have Telefonica slides, and at the bottom we also have the Intel ones. Okay, so what's the objective of this workshop? The idea is that we use OpenMANO to create a BNF. So we are going to use OpenMANO to develop a scenario that is going to include a few machines that are going to be the one that is going to become a BNF, and the other ones that are going to be used to test it. In this case, we are going to be using a traffic generator, a traffic sink, and the BNF, plus an additional machine that is going to be just a gateway to access to this environment. So we're going to use OpenMANO to deploy this scenario. Then we will enter into the machine that we are going to convert to a BNF, and we will compile the DPDK example L3 forward. So we will see how the traffic we are sending from the generator is reaching the sink. And we will see that as we are doing everything in a personal PC, the throughput is not going to be very high. So the second part of this is that after we have an L3 forward that is functional, but we are not able to see that is allowing to transfer the packets at 10 gigabits per second because the laptop is not allowing it, is not allowing that speed. What we are going to do is we are going to save the image, we are going to save the BNF, we are going to send it to a real pool of servers, and we are going to instruct OpenMANO that instead of deploying in our PC, it's going to deploy in a real pool of servers that is in a remote location. So when we deploy it in that remote location, we will start the generator and we will see how the traffic sync is receiving traffic at 10 gigabits per second. So that's the whole process we're going to be. So the first thing we need is to have an OpenMANO to use it to deploy the scenario. We have a virtual machine called OpenMANO CentOS. This name is just because it's an OpenMANO installed in a CentOS. It could be a Ubuntu. There's no problem about that. So we have started it and we should be able to SSH it. SSH DPDK at sorry, I have to use the IP. It's not going to resolve it. 10.10.03. Okay. Okay. So in this machine we have the OpenMANO. We just did the install openmano.sh, and now we have to go through the configuration to start using it. We also did the configuration, but I want to show you what these changes were. So Beam, OpenMANO, OpenBeam, OpenBeam.d.cfg. This is the configuration for the OpenBeam. Okay, so let me go to the beginning. Here we say the mode. The mode when we download and install the OpenMANO is, I think, test or normal. Let me explain briefly what these modes are. Normal is as its name says, is the normal behavior. We are gonna deploy against a pool of servers, and we are gonna make the connections using OpenFlow instructions using a real switch, data plane switch. The test mode is just to check that the scenarios we are defining are okay, but it's not gonna deploy anything. That we are not gonna create virtual machines, or we are not gonna create data plane connections. Host only is a mode in which you just don't use the switch, the data plane switch, but you deploy the BNFs. And development mode is the one that we're going to be using in here. That is a mode that fakes the descriptions. I'm going to explain what this means. I'm using a normal PC, not a real server, and therefore I don't have 10 gigabit interfaces, and I don't have much memory. I'm not using huge pages. I don't have many CPUs. So in this mode, what we get is that I'm gonna create a BNF descriptor to describe my BNF, but the things I'm requesting in that descriptor are not the same that I'm gonna be obtaining. For example, I'm gonna request for the L3 forward to have two 10 gigabit interfaces. What the OpenMANO is gonna do, since we are using the development mode, is that instead of giving me two pass-throughs of 10 gigabit interfaces, it's gonna provide me two bridge interfaces. This is valuable since it allows me to start working, to start programming my BNF using a normal PC instead of going to a server. Okay, so in case we are working with a switch, we have to configure where we have the OpenFlow controller, the DPID of the switch, and the only other thing we just edited the mode, and the only other thing we edited was here in the bridge interfaces. We have a set of bridges, and we added the BIRBRCon. Is just for the connectivity we use it during the workshop. This is not important, but it's the only other thing we modified. Here you can define as many bridges as you want and assign them different VLANs, so you can attach different bridges to the same interface using a different VLAN for each one of them. Okay, so now that we have seen the configuration, we want to start exporting variables. Here in the .bash rc, we have already exported the OpenBeam host and the OpenBeam port. These are the default values. Okay, so the next thing we have to do is to add a host in this directory, the jumps directory. We have a server that is developer host. Okay, this descriptor this is the IP that we have in our local machine. This is the name of the user we are going to use to connect, and we have a description. We are providing a fake description, so our OpenBeam is going to believe that we have a lot of resources. It's going to believe that we have a lot of CPUs, that we have a lot of 10 gigabit per second interfaces, and so on. But as we are in the developer mode, this is just in order that in our database we're going to be reserving the resources according to this description. But when we deploy, the real thing we will be deploying will be with not so much memory, with not so much CPUs, and using normal interfaces instead of data plane interfaces. So this is going to be just for development. Okay, so the first thing we have to do is to add the host. So openbeam host add. Okay, and we use the Jams developer host that I just showed you. Okay, why I got connection refused? Because I forgot to start the service. There is no an OpenBeam running, so I cannot connect to it. So to start the three services that are going to be Floodlight, an OpenFlow controller, the OpenBeam, and the OpenMANO, we do a service OpenMANO start, and this is going to take a few seconds, but it's going to start all three components. Okay, so I pause and unpause just to save a few seconds. We have the three components running in three different screens, and now I should be able to add the host. Okay, this new host has been created. We can also do a host list to check it's in there, and using the verbosity option we can see the description of it. Okay, it's in there. The next thing we are going to do is to create networks. We want to have available two different networks, although we will use only one during the workshop. So openbeam net create. Okay. We have also the description here. John's BBRCon. Okay, we have it created, and we are gonna also create the default one. But in this case, we are gonna create it just on the fly. So network name default. The type, it's gonna be bridgeman. Okay. External network true, yes. And this is gonna be bridge. Okay, bridge name, this is gonna be default. This is default, yes. Okay, what we have created is just a network that is gonna create the default network. That's why I was laughing. Okay, so if we do an openbeam netlist, we have these two nets we have created, sorry. So the bridge con and the default. Okay, so these are the two nets we have just created. Now we have to create a tenant for the openbeam. So tenant create minus name mybeam tenant. Okay. Tenant description. Okay. So we have it created, and now we are gonna export this to also to a variable. So we can use it later. And we save it for later in case we just log out and log in. Okay, now we create the OpenMANO tenant. We need to create a tenant for OpenBeam and also a tenant for OpenMANO. OpenMANO tenant create my tenant. Okay, and again we save. Come on, OpenMANO tenant. Oh, I just overwrote the .bash RC. Okay. Okay, I'll solve it later. I just have to remember not to log out of the screen. Okay, OpenMANO tenant, and we're gonna configure now the GUI, since it's gonna use this OpenMANO tenant. Vim OpenMANO GUI config PHP, and here we set this OpenMANO tenant. Okay, now we're gonna create a data center. And this data center is gonna be pointing to our OpenVim. Data center create my data center HTTP local host 9080 open vim. Okay, so that the center has been created, and we are gonna also export this. Okay, and now that we have created the data center, we are gonna attach it. So I think it's Vim tenant ID and OpenMANO open. A frequent error is to use the wrong tenant. This is the OpenVim tenant. Okay, so now that we have the data center attached, we have to update the networks. So we make available for OpenMANO the same nets we defined for the OpenVim. So data center net update MyDC. Yes. Okay, so we have inherited these two nets, so they are available now for OpenMANO. And now we are ready to create to include in OpenMANO VNFs. First, I want to show you that the GUI should be available. Okay, we don't have scenarios. We didn't define anything. For the VNFs, we only have these two ones are always available. This it's by This is included in OpenMANO, but the external networks, these are the two ones we have just defined. And if we go to the physical, we have the developer host, that is the one we define. So what we're gonna do now is to create the BNFs, so they are gonna become available in here, and to define a scenario. Okay. So also in the YAMLs directory, we have defined 3 BNFs, actually 4, because we are going to have a gateway, the L3 forward, the generator, and the sync. Okay, we're going to do everything using the CLI, and using the GUI, I will show you the scenarios so you understand better the schema. So OpenMANO BNF create YAMLs, come on, okay, L3 forward, okay, gateway, PKDGen, and sync. Okay, so we have the 4 BNFs available. If we refresh, they are in here. Okay, and now we're going to define this scenario. So OpenMANO scenario create jams scenario. Okay, let's take a look to the definition of the BNF and the scenario. Okay, here what we have is the name the interfaces is gonna have. As you see here, we are saying that we have an interface that is of management, of type management, but two of them are data. This means these are 10 gig interfaces. We have it here in this description. And when we deploy using OpenMANO using the development mode, these are going to be deployed as 3 management or normal interfaces. But when we deploy using the normal deployment, these two are going to be real data plane interfaces. That's how OpenMANO is allowing us to deploy to program a BNF here in our PC, and when we deploy it later in a real data center, as we will be using an OpenBean configured in normal mode, the BNF will be deploying with a full capacity. Okay, so we're gonna see the scenario. Okay, this information here is just graphical information, is not needed for creating a scenario. It's just to represent it properly in the graphical interface. Here we have the connectivity among the different elements. Okay, connections. Okay, we have it a little bit mixed. Sorry. Okay, so let's go in order. So we have the name of the scenario, the topology that is going to be composed of nodes. The first node, the gateway. This graph information, this is the extra information is not needed, but the type BNF and the BNF model gateway, this is the name we gave to the BNF. This is gonna be one of the nodes included in our scenario. The second one is gonna be the L3 forward, then the packet gen and the packet sync. And we will be using the bridge con for providing connectivity. We will also be using a bridge net to create a point-to-multipoint connectivity, and these are the links that are used. Okay. So if we go to the scenarios, we have here DPDK training, that is what we have just created. Okay, so this is how it looks. We're gonna have the generator that is gonna be sending traffic to the L3 forward, that is gonna forward it to the sink. So all the traffic we generate, we should receive it in here as soon as we have the BNF properly created. I mean, with the L3 forward example properly compiled. The gateway is only gonna be used for accessing because now when we are deploying in our local machine, we won't have problems to access to these three machines. But when we deploy in a remote environment, it's very convenient to have a gateway. So knowing this IP, we can access to our whole environment. The full definition we have used can be seen in here. See as text, we have the full definition. An alternative we had to create this scenario, instead of defining it using the CLI, would have been to just draw it. So we could have done this as well. Just drag and drop the three BNFs and the gateway to allow access. Okay, and BridgeNet to provide connectivity. Okay, so we can start drawing. Okay, these are the management interfaces. And these are data plane interfaces. Okay, so as it's more convenient for us, we have it already drawn. Nice. Okay, and the only thing we have to do now is to just deploy. Okay, in this deployment, the gateway is working as a gateway. The packet gen and packet sync are properly configured, but the L3 forward is just a plain CentOS. So we have to get in there and compile and compress the DPDK, download it from dpdk.org, and compile the L3 forward example. So the first thing is to deploy. Okay, it's asking us for a name for the instance. It's okay to use the same name, and we get a result success. Okay, this means it's already starting the. Okay, okay. So we have a problem connecting from the virtual machine to the host machine. It's probably because of the SSH. So if I try to SSH 10.10.0.1, okay, this is the error we're getting. The problem is that this OpenMANO virtual machine I'm using was in another machine. So as I have moved it, it's having a problem with the known host information it has. So I'm gonna just remove the whole known hosts. Okay. And why is asking me this password? This shouldn't be like that. It should allow me to connect directly. Oh, yeah, because I'm using user DPDK student. Okay, now it's compulsory that we have an SSH exchange, so the OpenMANO is able to log in all the compute nodes. In this case, the compute node is our own PC, the bare metal. Okay, so now it's ready. So what we're gonna do is to rebuild everything. Success. Okay, so it was quick. Now we have all the elements running. If we open the Build Manager, we should be able to see everything. Okay, these machines are running. I'm gonna open the gateway to see what IP is using. Okay, so I'm gonna open the console. Okay, the Build Manager was still in my mouse. Okay, so file, open terminal. It's gonna be SSH, DPDK at. Yes. So now I'm at the gateway. Open tab and open tab. I'm gonna open 3 tabs so I can access to the 3 elements. Okay, so with the first one, now we are in the gateway. Okay, let me show you. We are in this gateway. We are gonna SSH to these 3 elements. This is gonna be the point 2, point 3, and point 4. Point 2 is the generator. Okay. SSH point 3. Okay. And point 4. Okay, so we have the sync, we have the gen, and we have a machine that is called DPDK that is just applying CentOS. Okay, so in here we have the dpdk.org folder that contains the code downloaded from dpdk.org, and we also have some scripts to automate the BNF start. So what we have to do is to uncompile the DPDK, to compile the DPDK, to compile the L3 forward example, and then we will show how the generator is sending traffic to the sink through the L3 forward, but we will not have a big performance since we are running everything in a normal PC. The idea is that once we know that the L3 forward is running, we save the image using OpenMANO and we deploy in this remote server. Let's change directory to dpdk.org, where we have the 2 patches that we will have to apply to the L3 forward and the dpdk tar. So let's untar it. Okay, and now let's move to the upper directory where we have a soft link that's called dpdk. Okay, and we are gonna copy these 2 patches to the L3 forward directory that is in the examples of dpdk. And why we have to do this is because we are gonna use extra parameters in the L3 forward in the invocation that are not available in the current example. They will be, but not at the moment. Okay, so now we have to compile the DPDK. So sudo -c dpdk tools setup.sh, And now we have here option 9, that is the compilation for native Linux app GCC. But first we're gonna exit because we have to configure in order to compile DPDK as default. Why we are doing this is because the processor in the PC where we are and the processor in the remote servers are different. So we are gonna use a more relaxed set of instructions so it's compatible with both processors. So we have to edit the file in DPDK config. It's dconfig x8664 native Linux apt GCC. Okay, so we have to change the config RT machine that is saying that it's native. Let's change it to default. Okay, so now we can do the setup, and now option 9, that is gonna compile the full DPDK. This is gonna take a while, so what I'm gonna do is that I'm gonna pause the video and resume it when it's ready. Okay, so the compilation has finished. Now let's insert the IGV UEO module, that is 12. Okay, now let's include Hue pages or set up Hue pages, that is gonna be 15. Okay. Okay, and the last thing will be to include the cards to use the EGV module. That was 18, but it's not gonna work now because the interfaces are up. So okay, so okay, so if I display them, okay, we can see as these two cards has been moved, so now can be used by DPDK. Okay. Now during the course, during the workshop, what the Intel people did was to start manually the L3 forward. What I'm gonna do, just to save time, is to use the auto start. This auto sh link, what is gonna start is this other script that is just the only thing that it does when the machine starts is to communicate with the generator and with the sync, so it obtains the MAC addresses and then it starts automatically using those parameters the forward. So I'm gonna just move the auto sh insert to change the name. Okay, so now it's ready to auto start, but the one thing we didn't do yet is to compile the L3 forward. We have the DPDK compiled, but now we have to compile the example L3 forward. So DPDK examples L3 forward. Okay, here we have the patches we copied before. These two patches are going to be included in dpdk.org. Are going to be included as part of the code, but here we had to patch it to in order to be able to use extra parameters to include the MAC addresses I was saying the automatic start it will include. Otherwise, we will have to configure manually in code. So let's apply patches. Okay. And now let's modify this define that was also required for the functionality uh, we want to use in the L3 forward. Okay, so now we are ready. The make clean doesn't make sense since we just uncompress the DPDK. So now we have the L3 forward compiled. So what I'm gonna do is just to restart this virtual machine so the functionality automatically starts. Okay. Let's try to connect again. Okay, it's already up. And if everything is okay, the L3 forward application should have started in on a screen. -X. Okay, so it's already running. Here we see how it's matching its two interfaces that are these two ones to the other end interfaces that are the generator and the sync. These two max in here have been obtained by the script. Okay, so now what we have to do is to start the sync. Okay, we're ready to receive. The generator, it's the same program, just in the generator we are going to emit and in the receiver we'll see the traffic. So it has automatically detected this destination MAC, that is the one of the L3 forward. And doing a start 0, we start sending traffic. Okay, we see as we are sending traffic, and we see that we are hitting like 50 megabits per second, 20 something. When we deploy this in the real server, we will see that we are going to be hitting almost the 10 gigabits per second rate. Okay, so now let's go to the sync, and we should, well, okay, we are seeing that. We should see how we are receiving this. We are here receiving like 10 megabits per second. It should be in case, okay, we see that in the L3 forward we are also having some losses. Okay, in the real server we'll see that the same amount of traffic that is being sent by the generator will be receiving by the sync, since the L3 forward is being able to forward all traffic with no losses. Okay, so up to here the DPDK example. We have now the machines working. So what we are going to do now is to save the L3 forward, to save an image, actually an incremental image, only the differences among the actual state of the image and the one we had when we started. And we are going to copy to the remote server to do the final test. Okay, so in order to be able to access to our scenario in the remote server, we are going to add an additional modification, that is to set a specific IP for the gateway. So when we want to SSH later, we will be able to reach it. Okay, so for example, here, quit. Okay, we go back to the gateway. Okay. And we enter to configure the DH0. Here we're obtaining the IP address as DHCP, but we're gonna use an static IP. Okay, so this is gonna be, for example, 10, 95, 87, 239, 255, 255, 255, 128. The gateway is gonna be 10, 95, 87, 29, and DNS is gonna be, let me remember, 1095, 121, 180. Okay, these are the values that I know that I have to have in the remote environment to be able to access to it. Okay. During the workshop, we gave to the students a little sheet saying all the configuration that each one of them should have. Obviously, every student, every computer was having a different IP for the gateway, so all of them were able to access to the gateway at the same time. Okay, so we already have the L3 forward and the gateway modified. So let's move to the OpenMANO console. So we save these incremental images to deploy in the okay, a necessary step to allow connectivity to the remote environment is just to add a route to that we have scripted. Okay, so okay, route has been included. Let's ping our remote beam. Okay, we can reach it. So now, as I was saying, let's go to our OpenMANO. If we do an open beam VM list, we are gonna see all the VMs we have, the 4 VMs running in our scenario. It's saying that all of them are active. So what I'm gonna do is shut down of them. The -F is just in order to avoid the prompt asking me if, for confirmation for each one of them. Okay, so it's shutting down all of them. And now it's gonna take a while till, okay, it's already doing it. It's modifying from active to inactive, saying that the machines are shut down. Okay, so now all of them are shut down. It's safe to create an image from the current state of the virtual machines. So open VM create image from the image of L3 forward. I'm gonna call it my L3 FWD. Okay, yes, and I'm gonna do the same. Create image for the gateway, since these are the only two machines I have modified. My gateway. Okay, in the remote server, in the remote pool, I have the images of all these 4 virtual machines, the original one, the base. So as I'm gonna copy these 2 incremental ones, I will be able to deploy in there the same environment I have in here, the same scenario. The only difference is that when I deploy in there, I'm gonna use an OpenB that is working in normal mode. That means that we are gonna be deploying over a real server using real 10 gigabit interfaces and making the connectivity of the data plane using a real switch. and we're going to make that, or OpenMANO is going to make that connectivity automatically using OpenFlow. Okay, so what we're going to do to do this change is to use a script we prepared for the workshop. This is only because it's easy to make a mistake while doing the following. That is, now we have an OpenMANO in this virtual machine running in our PC that is pointing to an OpenBeam that is running in the same virtual machine that is working in development mode. What we're going to do is to point to a different OpenBeam that is going to be placed in our remote environment that is going to be working in normal mode. Okay, since the OpenMANO at the moment is not able to work with multiple data centers, what we have to do is to undefine everything, undefine the BNFs, undefine the scenario, undefine everything, point to the different OpenBeam, and then define again. That's why we did this script. Okay, so I'm gonna run now the script, and it's gonna be pointing to the new one. Source training, change to server, and I have to say the IP of the remote OpenBeam. Okay. Okay, it's asking for confirmation. Okay, and it's in verbose mode, so it's showing all the actions that is doing. Okay, it has completely changed. It has redefined the BNFs. It has redefined the scenario, and now it's asking me to perform some actions. Okay, it's asking me to create a directory. This it's a random number. This is the number that has been assigned to me. So multiple users could be doing this at the same time. Each one of them will have a different random number, so our BNFs are not going to be mixed up. So I'm going to create this directory, and I'm going to copy to that directory the two incremental images that I have in home static storage, my gateway, and home static storage, my L3 forward. Okay, this is in the host, that is the one that is storing the images, because you have to remember that we are using this virtual machine that is the OpenMANO that is deploying over the host that is our PC. Okay, so let's select this, open a new tab. This is our host. Okay, create directory, and now the two SCPs are gonna take a while. This one is not gonna be too big. Okay, 10 seconds. Okay, it's increasing. So what I'm gonna do is I'm gonna pause the video, and I'll resume when the two images has been copied to the remote server. Okay, so as you can see, we have the two files copied to the remote location. The only thing we have to do now is to deploy the scenario. So let's do it from the graphical interface. This is showing the all information. We just have to refresh. Okay, so the new scenario is my DPDK training. It has been created automatically by the script. It's exactly the same scenario than before, but we changed the name. The script changed the name just to make it evident that it's not exactly the same scenario. It has the same components, they are connected in the same way, but it has defined again the scenario when we change it from one OpenBeam to the other one. So let's just deploy. Okay, the instance name is going to be the same, and we should see, okay, here it is, just success. Okay, click the instance, it's deploying. Let's click update. Okay, all of them are running. So this means that we should be able to reach DPDK at the IP we gave to the gateway 10.95.87.239. Let's see if it's available. Okay, DPDK. This is the same in another terminal. Tab. Okay, okay, okay. Let's connect to the sync. This is the gen. The sync is the dot fork. Okay, and the gen. Okay, okay. So we have here the generator. pktgen.sh sync. Okay, so the sync is ready. The generator is ready. Start 0. So we see that the generator is sending traffic. We are seeing 9.8. It's the generator is not being able to reach the 10 gigabits per second, but it's very close to it. And we will see that the sync is receiving the same amount of traffic. That means that the L3 forward is forwarding traffic using the data plane interfaces at full line rate, 10 gigabits per second. So until here the workshop, here we finish. We have seen how to use OpenMANO to create a scenario, how to deploy this scenario in development mode, so we can use it in our PC. We have seen how to compile the DPDK and to compile the L3 forward example. We have tested it in our PC, and then we have pointed our OpenMANO that is running in our virtual machine here in our PC to a different OpenBeam that is in a remote location, so we can deploy over a server, so over a real NFV pool. And after deploying, we checked that the L3 forward was running properly. So I hope you enjoyed it, and see you soon.